Limits.
It is a foundation of some of the most intricate and complex levels of calculus, yet can be simplified as the value a function approaches as the function's input gets closer and closer to some number. In other words, it's a value that we can get as near as possible to, but never quite reach. Almost like a car driving over a partially collapsed bridge. It can get as close to the ledge as possible, but it'll never be able to drive over that collapsed part. Applying this concept mathematically, let's take for example the function f of x is equal to x minus 5 over x minus 5. Now you may be thinking, same numerator, same denominator, so we can just cancel them and get 1.
But it's not quite as simple as that. Although it is true that the equation would equal 1, it has parameters because if x is equal to 5, then the denominator would become 0, thus undefined. So we say that f of x is equal to 1 where x is not equal to 5. On a graph, this function would look like this, with this point representing the point that the function is undefined. We can add an additional condition saying that when x is equal to 5, f of x is equal to 3. For a limit to exist, we have to ensure that the limit approaching the value from the left and the limit approaching the value from the right are equal. In this case, we see that the limit exists because these conditions are met.
But let's confer on the concept of continuity. Now, continuity is used to describe functions with no abrupt jumps or breaks. For continuity, the limit approaching a certain value has to exist. Also, the function must be defined at that point. Lastly, the defined point and the limit must be equal. In this graph, we see that when x is equal to 5, f of x is equal to 3. But the limit as x approaches 5 is actually equal to 1. So this function is not continuous.
The sky is truly the limit when we can understand the concept of limits.